In the xy plane, a circle has center C with coordinates h, k. Points A and B lie on the circle. Point A has coordinates h positive 1, k positive square root of 102. And angle ACB is a right angle. What is the length of AB? Okay, first let me draw a circle. Okay, here I've drawn a circle and let me plot the center C with coordinates h, k. So here we have the center C, h, k. Okay, now let me plot the point A on the circle because the question says points A and B lie on the circle. Okay, so and also we have the coordinates for A, h positive 1 and k positive square root of 102. Okay, now let me plot the point A over here, that is A of h positive 1, k positive square root of 102. Okay, here we have a question. So how can I decide that the point is A over here? So because the point A is on the circle, it can be marked at anywhere on the circle. Here we can mark the point A on the circle, or here at anywhere on the circle. So why I particularly mark the point A over here on the circle? For that, we can consider the x-coordinate of the point A, that is h positive 1, and the x-coordinate of the center of the circle, that is h. So here at the point A, the x-coordinate h positive 1 is greater than the x-coordinate of the center h by 1. Since this x-coordinate is greater than the x-coordinate of the center by 1, so the point A should be to the right side of the center C. And also, let's consider the y-coordinate of the point A, that is k positive square root of 1 and 2, and the y-coordinate of the center, that is k. Clearly, the y-coordinate of point A is greater than the y-coordinate of the center of the circle k by square root of 102. So, the point A should be above the center C. So, clearly, the point A should be to the right side of the center C and also above the center C. That's why I have marked the point A over here. Okay, now let me draw a dotted horizontal line segment over here from the center of the circle, and also let me draw a dotted vertical line segment from the point A to this horizontal line segment. Let me finish. Okay, here we have a right angle, and also let me connect the center of the circle and the point A over here. Now I got a right triangle over here. And what is the length of the horizontal line segment over here? To get the length of this horizontal line segment, we have to find the distance from the x-coordinate of the center H to the x-coordinate of the point A. So what is the distance from H to H positive 1? Clearly, this H positive 1 is greater than this H just by 1 unit. So that 1 is the length of this horizontal line segment over here. Okay, what is the length of this vertical line segment? For that, we have to find the distance from the y-coordinate of the center K to the y-coordinate of the point A, that is k positive square root of 102. So what is the distance from K to K positive square root of 102? So clearly this K positive square root of 102 is greater than this K by square root of 102. That square root of 102 is the length of this vertical line segment over here. Now, in this right triangle over here, this AC represents the hypotenuse because it is opposite to the right angle. We can use Pythagorean theorem to get the length of this hypotenuse AC. So, according to the Pythagorean theorem, the square of the hypotenuse, that is AC square, equals to sum of the squares of other two legs. The length of this leg is 1. So, 1 square positive. The length of this leg is square root of 102. So, then we get square root of 102, the whole square. Okay, here this square and square root will cancel out. Then I'm getting AC square equals to 1 square is just 1, and here we have 102, and AC square equals to 1 positive 102 is 103. Okay, now to get rid of this square over here, we have to take square root on both sides. Okay, let me take square root on both sides. Then the square root and square will cancel out. We get AC on the left side. On the right side, we have square root of 103. Usually when we take square root on both sides of an equation, for this square root we consider positive or negative sign, but here I consider only positive sign for this square root because this AC represents the length of the hypotenuse of a triangle. It can never be a negative value. Now I got the length of the hypotenuse AC of this right triangle, that is square root of 103. And also this AC represents the radius of the circle. So the radius of the circle is square root of 103. Now we have to mark this point B on the circle so that angle ACB is a right angle. Okay, now let me mark the point B over here, and also we have to make sure the angle ACB has to be right angle. Okay, now let me connect the point B on the circle and the center of the circle C over here. According to the question, the angle over here is right angle. That is ACB is a right angle. And now let me connect the 2 points A and B. 1 second. Okay, so here. Okay, now I have connected the 2 points A and B. Now my aim is to get the length of AB, that is the length of this red color line segment. Okay, here this BC also represents the radius of the circle. Already we got the radius of the circle, that is square root of 103. Then the length of BC also the same, square root of 103. Okay, here ACB is a right triangle because we have right angle at the vertex C, and also it is an isosceles right triangle because the two legs are equal in length, BC and AC. And the side AB represents the hypotenuse of this right triangle because it is opposite to the right angle. Okay, in an isosceles right triangle, there is a concept, that is we have to assume x as the length of each of the two equal legs. That is we have to assume x as the length of the leg BC and the same x should be considered as the length of the leg AC. Okay, when x is the length of each of the two equal legs, then the length of the hypotenuse has to be x times square root of 2. That is, this x has to be multiplied by square root of 2 to get the length of the hypotenuse in an isosceles right triangle. But already we have the value of this x, that is the length of BC and also the length of AC, that is square root of 103. Now we can plug in the square root of 103 for this x over here. Then we get square root of 103 times square root of 2. Okay, here we multiply two square roots. Whenever we multiply two square roots, we can take square root in common and we can multiply the values inside the square root, that is 103 times 2. Then we get square root of 103 times 2 is 206. So the length of AB is square root of 206. We find this value exactly in answer choice A. The correct answer choice for this question is A.